Good afternoon, ladies and gentlemen. Thank you for joining us today for the webinar titled The Role of Geology in the Industrial Minerals Value Chain. This is presented today by Eric Ronald. My name is Jackie, and I will be serving as your host for today's session. Attendees may submit questions at any time during the presentation by using the chat panel, and the host will read the questions aloud to our speaker during the question and answer period following the presentation. This webinar looks at how geology and geologists fit within the industrial minerals value chain, from exploration through operations to marketing and research and development. Eric Ronald is a principal consultant with SRK Consulting in Denver. He has over 20 years experience in the mining, mineral exploration, and resource geology fields. I'm now pleased to turn the session over to our speaker. Eric, would you please share your screen with us? We see the presenter's role, and now we see the full screen. Excellent. Please proceed.
All right, well, thank you, Jackie. Good afternoon and welcome. Thanks for everybody who is attending. I very much appreciate it. Jackie gave you a nice introduction there, and you've obviously seen the abstract. So what I'll be doing today is taking a look. I'd like to first introduce the concept of the value chain, which may not be as familiar to most, especially those with more of a technical discipline background, and then really how geology and geologists tend to fit within that value chain. Now, I will be focusing a lot on industrial minerals, but I also plan to compare and contrast how geologists typically work within the mining industry in a more traditional commodity sense, base, precious metals, things of that nature. All right, well, let's roll right into it. Here is an introduction simply on what the value chain is. I wanted to introduce this concept to get everybody on the same page because it's pretty critical for the purposes of this talk. So really, a value chain in this context is that interconnecting, say, steps or processes that essentially create value for a company. So in mining, this typically starts with an ore body or the deposit, and it's exploited and understood through typical exploration means. It starts with a geological anomaly with some potential to be economically extracted for material, mineral, metal. This is then optimized through mine plans, say for an open cut or underground, depending on the nature of the deposit, and then finished with processing, recovery, and finally logistics and sales. So this is what you see in a typical mining package from a value chain. We tend to talk about this from an upstream to downstream sort of scenario. Probably a better way of thinking about this is sort of a circular chain, and this is with that value chain. So here's the exact same thing, just imaged in a bit of a circle. There's the starting point, like I mentioned, kind of starting with exploration, and the end is when you've got a final product that's sold off into the market. So you can imagine looking at, say, a gold exploration project. Eventual product is essentially gold bars or ingots. That's then shipped to market, sales on the open market, done. That's it. So when we start taking a look at industrial minerals, and what is so special about that? Industrial minerals tends to be primarily a market-driven entity. From more of that traditional mining perspective, this really might look like putting the cart before the horse. In most cases, industrial minerals are not openly traded on global exchanges as compared to a lot of commodities, gold, copper, things of that nature. Prices and contracts can be very opaque, and markets sometimes are extremely niche to the point where oftentimes you'll see servicing of a single customer. So it doesn't go out to a broad market. Industrial minerals are absolutely not about making those shiny bars of metal, knowing you can easily sell it in any sort of global market. In industrial minerals, we often see a reaction to changing demands. This is evidenced by when we see recent booms in, say, the battery and energy storage markets, where we've seen things like lithium and cobalt and these other products becoming more and more commoditized and really sought after. Another sort of unique item of industrial minerals is really the processing and refining, where in a traditional metal sense, a lot of times it's simply trying to improve a recovery because you're trying to extract, say, a metal. But with industrial minerals, really the technology, the research development tends to be heavily focused on the processing and refining. Essentially, when you start thinking of industrial minerals, the physical and chemical properties is what is being sought after. So if you can modify those properties, especially on the physical side, to provide better end uses for the customer, this is often done through the processing. Um, Another interesting thing when we start getting into different industrial minerals is substitutions. Um, there are multiple minerals that can be used for similar applications. So you start thinking about things like filtering, pigments, paint, things of plastics of that nature, where a new lower cost product can disrupt that industry and supplant a different mineral based on cost and or performance. Um, as I mentioned before, industrial minerals, some of the definition is why they're an industrial mineral, is they are economic. There's a market for them. They can be sold because primarily they're physical and chemical properties, as opposed to, say, their metallurgical properties with more traditional metals. In industrial minerals, this is a pretty broad general statement, but a lot, the margins tend to be low. Now, obviously, when we start talking about things like lithium, that's a bit of a different animal, but again, this is a bit of a broad sweep. So when you compare that, you know, uh, with traditional mining, those lower margins means that distance and infrastructure can absolutely kill a project. Um, if you find a high grade gold project, say in far eastern coast of Greenland, well, you can probably make that swing if your grades are actually, pretty good. But on your way to that high grade gold deposit and you step across a world-class wollastonite deposit, for instance, well, forget about it, right? It is not going to compare. So these are things that need to be understood a bit better, is that distance to market and availability of infrastructure are absolutely key to most industrial minerals. Um, we also start thinking about R&D, and R&D is one of those that a lot of folks with a traditional mining background sometimes struggle with. R&D is really the key for most industrial minerals companies to stay competitive. Finding new applications for product, it's really a big part of the game. Oftentimes you'll see producing companies, having to partner with their actual end member customers or end use customers to develop new applications together. You'll certainly never heard of this of a coal company, partnering with an end user to try to come up with new research and development for that. So you're starting to get an idea of there's some fundamental differences about industrial minerals compared to that traditional mining markets. So if we take that example of that kind of circular value chain, um, this would be a generalized example of, say, industrial minerals company value chain, really with the size of that box related to kind of that perceived importance for most companies. And again, I'm making a very broad generalization, but a lot of times, as I mentioned before, processing is huge and justifiably so, as well as marketing of these, and R&D is quite high. And if you look and squint up in the upper left, you'll see things like exploration and over in the left side, mining. In a lot of companies, it tends to be a bit of an afterthought. And unfortunately, I think this is where a lot of geologists within the industrial minerals world, they tend to get stuck in some of those unloved areas of those small boxes that we see over there. Um, so we think about exploration, and I love to compare and contrast this with, say, a copper project. You look at copper exploration and work I've been involved with in the past. If you want to find copper, you go to elephant country, they say, right? Where are the great big copper deposits? Where are the high grades? So you find yourself in, say, Central African Copper Belt, the Cordillera in South America, or perhaps in Central Asia. Contrast that with, say, talc exploration that I've been involved with. And the very first thing was not go find the biggest, the best, the highest grade. Was, well, find the mandate that we had was find something within about 100 kilometers of our mill. Oh, okay. Well, from a geologist perspective, it's almost laughable, but that was sort of the directive, that if you're beyond 100 kilometers, logistics will kill your margins and you can't do it. And you just hope and pray you've got the right rocks within 100 Ks of your mill in that case. So industrial minerals value chains, like I said, they're not always that simple. I like to compare some of this to being absolute spaghetti bowl when you start looking at these. And so it's nice to have a pretty little graphic that it goes around in a circle, but it's really interconnected. It's a lot more complex. As I mentioned, if you're looking at exploration and you're constrained by logistics and distance, all of a sudden, can you do that? How are these things involved? So it's not straightforward. I mean, this is one of the beauties and one of the curses of industrial minerals. Um, it can be a complicated, confusing business where you have individual minerals or products that may serve over 20 different markets. And then within each of those markets, you can have demand range for a variety of different minerals. And so you can imagine this thing starts getting to be very messy and very confusing. And yeah, I have to acknowledge Mike O'Driscoll, who lent me this slide. This is a fantastic example of just, there is competition out there, there is substitution out there, and just because you've got the world's best magnesite deposit doesn't necessarily mean you're not going to be out competed from another product, another mineral in a variety of different applications. So these are important things, I think, from a geology perspective and from an industry professional perspective, to understand your market, understand your mineral, who are the competitions, what are some of the potential risks for the company. And this goes beyond just understanding the rocks as a geologist, in which most times that's your mandate. What are the rocks for this deposit? How do we best utilize this? But to understand the broader picture in industrial minerals takes a lot of time and it takes a lot of work, and I think is required for success. So I mentioned margins and pricing. So here's another slide that I pinched off of Mike. This one's here a bit dated. It's about 3 years out of date, but it gives you an idea on some of the ranges that we see within industrial minerals pricing. So it's all over the board, right? And so when you're dealing with things kind of on the lower end of the side, where we've got things like the bauxite, chromite, limestone, frac sand, all the way up to sort of the rare earths and lithium that gets its own little box, as you can see. These are things that, there are consequences, I would say, to not having those fantastic margins that are also things to consider, and the things that are real issues within industrial minerals in a lot of cases. So what happens when margins are small? All right. And I use these pictures as an extreme measure where your sorting and your mine geologists might be manual labor. It's pictures from, I believe this is a talc mine in India. Your primary mining tool might be a little bobcat with a rock crusher, and your plant and your processing, well, it might be a mobile crusher. So in cases like that, sometimes the agility of being small is fantastic, and sometimes it's an absolute hindrance. So what are some of the characteristics you often see when the margins are small? Really a limited capital, and obviously it's difficult to raise funding. It's difficult to get a large influx of cash and capital, not only sustaining but actual growth capital. So a lot of times these are the necessity of an operations. On the other side, you tend to see fewer specialists and more generalists. And what I mean by that is that you get individuals who have to wear a lot of hats, whether this is operations or corporate based. So you don't probably have the luxury of having a site-based mine planner, medium-term mine planner, life of mine planner, maybe a drill and blast engineer, a surveyor, a couple of geotech engineers, a couple ore control geologists, so on and so forth, that you'd say at, say, a typical large metal mine. So the downside of that is things tend to get done at very general high level areas. So a lot of times that results in value lost or value left on the table. From an individual point of view, sometimes it's a fantastic thing. If you have to be the surveyor, the geotech, the geologist, and the mine engineer all in one, you get a concept of a lot of career development, to say the least. You tend to deal with smaller tonnages in most applications. You don't see the big Bingham Canyons, of course. There are a few exceptions out there with some larger industrial mineral operations, but they tend to run pretty small, pretty lean. Oftentimes you see shortcuts taken. This can be everything from a health and safety perspective to technical expertise to maintenance on equipment. Um, I was like this one, when you come up onto a site and say, well, how are you adhering to standards? And standards, what standards? And there's a lot of operations that tend to feel like they're flying under the radar. And don't get me started on some of the mine plans and the old, yeah, we got a mine plan. It's hanging on the wall right there. Like, I've never seen a mine plan hang on the wall, but it's somebody's gone in and they took a map of the mine. They started their color pencils and all right, we'll mine here this year, and then we'll move over here, and next year we'll be over there. We think. We'll see. When we get in there, we'll find out. And when we start talking about things of like reporting mineral reserves and mineral resources and ore reserves, a lot of times it just comes down to well, that's that stuff we're going to mine next year. And that dreaded question that I always hate, especially as a geologist. Well, what do we need a geologist for? Now, a lot of you who are listening in probably go, wow, this is a terrible representation of industrial minerals. And this is, I absolutely agree. This is some of the worst of the worst. But unfortunate, it is something that you do see and more prevalent in industrial mineral operations, and not just in North America, but around the world, where things tend to get done pretty poorly because of these issues. And I'm not saying that they're not successful mining companies, they're not successful industrial minerals companies that do some of this. But I guess what we're starting to look at is when we think of a value chain, we're thinking of how do we add value to a company? How do we maximize the ore body, maximize the deposit, optimize mining and processing? And each of these things that come out here is extremely negative. These are all essentially leaving money on the table. And these are things that I think can be addressed and should be addressed, um, and something that geologists can help with on some of these. So there was a meme going around the internet a while ago that was things like traditional role of mining. And I always like this. So, when I think of my career back in geology and, what are the thoughts of geologists in mining? And I always love, when I tell the people at the grocery store or friends who aren't in the industry what I do, they always think of some really cheesy Hollywood movie of Pierce Brosnan looking geologist running out of a truck and driving over volcano lava. And yeah, I have to laugh and just agree with them, of course, because we all look like that. And when you talk to engineers, of course, we're just a bunch of rock lickers, which is, I will take pride in that. And then there comes to be a problem then when we start talking to management. And when management fundamentally doesn't understand the value of a geologist, and they think, well, yeah, just let them play with their rocks. They'll throw it in the lab or they'll have a play with it, whatever, and it doesn't really matter. Then we start thinking, well, that's pretty bad. And of course, individuals think they stand on the mountain and solve everyone's problems. But when you start looking at what you actually do, and it's a lot of different things. It's juggling the perspectives of mining, of geology, of exploration, of business, but also within the processing realm and economics and logistics and everything else that kind of falls into it. You see this sort of wonky-eyed guy down here looking in many directions, but sometimes that's what it is. And a lot of geologists, especially in industrial minerals, are required to be able to wear lots of hats and maybe not be the world experts in some of these items, but at least to have a fundamental understanding. And that's where I think you can really see a lot of value being added. If you can get a geologist who not only is a good geologist, but understands what management needs, what the geotech needs, what the engineer needs, what operations need, so on and so forth, all of a sudden that can lend a lot of value. So we start taking a look at a traditional role of geology and mining. Really, most geos are heavily involved with upstream. And when I say upstream, if you remember back to the first slide, this is on really the exploration and the evaluation side. This is the E&E, finding ore bodies and evaluating and determining whether there is something there that's worth actual mining. When you start getting into operations, you tend to see less geologists, but the ones who are there, they tend to be involved more with ore control, grade control, really making sure what is the difference between ore and waste or different gradations of ore that needs to be fed into the mill. Um, there's others more on the corporate side, and this would be around the reporting of mineral resources, reporting for a public standards. This may be SEC, 43101, JORC. There's a lot of different standards out there based on which jurisdiction or exchange your company is publicly listed on. And then you see some of the specialist work. This would be geophysicists, geochemists, geostatisticians, folks of this nature, very niche, maybe come into an operation for, anywhere from a few weeks to a few months, bring them in for an exploration survey, and then they're gone. So, there's a wide variety of traditional roles you see. In general, you can kind of say there's a trend on a diminishing role of the geologist in mining, really starting from downstream. As you kind of get past that operation side, you see less and less geologists down there, and I think that's unfortunate. And then you get the bad companies who take that FIFO role of treating geologists. Well, just find me an ore body, now get out of here. And and those companies, they exist, and I'd say they suffer for it, which is unfortunate. So let's contrast this a little bit about the role of geology in industrial minerals. And I've taken this instead of like a little bit different approach. But if we go back and we recall that definition I gave of industrial minerals, it's really those rocks and minerals that are exploited for their chemical and or physical properties, right? And so when we start thinking what that means, well, deposit discovery. This is a geologist's job, right? Exploration discovery. Well, this is understanding what does the market need. And we talk about the latest trends in say lithium and in the junior space of lithium. There's been a fantastic uptake on this, and we've seen the increase in lithium exploration all over the world to some fantastic success, which is great. When we think about ore characteristics, who better understands the ore than the geologist? Well, there's ore, and there is a rock that's geologically interesting. And when I say ore, it's got economics to it. Can you sell this at a profit? Is it marketable? Is there properties here that are beneficial? We start thinking about those chemical properties. Well, is it going to meet the specs that our customers need? Those are the geochemical properties that go down to it as far as a chemical requirement. Well, that falls right into geochemistry and geology. In certain applications, the mineralogy is absolutely critical. Will it work for those final specifications? Will the customers be able to use it based on the mineralogy, either as a positive or a deleterious way? We start thinking about mineral resources that geologists work on. Well, really from a company's perspective, we want to know how much of the good stuff is actually there. Is this a mine that's going to be around for 6 months or 60 years? And that makes a huge difference in capital investment and whether a project even has enough NPV or rate of return to be able to move ahead. So geologists are typically, especially the ore control geologists, are used to dealing with variability within the ore body. Now we think about different ore types and different products that we can produce from an ore body. A lot of times that changes with time, right? And most of the time we see as you get deeper in ore body or as you go lateral extents to it, physical and chemical properties change. Well, how long can we produce the product we're producing right now? That falls into mineral resources as well, but that's a pretty critical thing. And then what happens after that? Do we see diminishing grade? Do we see a fundamental change in the product? What is the company's strategy beyond that? And then we think about blending options. And this can be blending within a pit, or this can be blending between two entirely different minerals. If we start looking at the benefits of different minerals coming together to solve a solution for a customer, well, that can be fantastic, but we need to understand what are the properties of those minerals that could come into that. And I think that's the things where geologists can really work with R&D. And then that all falls into the resource strategy of a company. What are those sought after deposits? What are those sought after minerals? What are those items that really can move the needle as far industrial minerals company wants to have in their portfolio? And that kind of wraps around to company strategy and what is the market going to need? What does the market need today? What does the market need in the future? As you see, it kind of wraps this whole thing back into there. So I've just outlined 6, 7, whatever it is, steps and questions that you see in industrial minerals that are asked on a very high level fundamental basis that in my opinion, and obviously it's biased here, right? But in my opinion, that geologists should be part of this conversation because in a lot of cases, they're the best placed to be able to answer or address some of these questions. So we talk about geologists in industrial minerals, but let's look at actually what makes a good industrial minerals geologist. Because I think there is something different between just a good geologist and a good industrial minerals geologist. Now, throughout my career, I've worked with some fantastic geologists who've had global experience in a variety of metals, commodities, environments, terrains, but that doesn't necessarily translate into success with them having the right mindset and experience to be successful in industrial minerals. Not saying they can't, but a lot of times it takes a bit of time. Because of all those other aspects that are critical for success in industrial minerals that a geologist tends not to be exposed to, a lot of times there's a hard learning curve in there. But I like to start at the fundamentals. So if you want to be a good industrial minerals geologist, it probably helps. It definitely helps. First and foremost, to be a good geologist, I'm just talking about fundamental geology, structural geology, mineralogy, petrology, understanding ore bodies, understanding genesis, understanding economic geology, and goes with it. If you don't have that, then yeah, we won't go down that path. So the next critical thing for industrial minerals geologists, I would say, is really understand all those aspects of the value chain. And I'm not saying to be an expert in logistics, to be an expert in detailed mine planning, but to understand and be able to understand how geology, how the rocks are affected throughout all this process. What are those sort of constraints? I mentioned earlier about that exploration constraint, about finding, a sufficient talc deposit that had enough quality, but within a certain distance. Well, why is that? And where are the areas that might be? There might be some wiggle room around there, right? And that makes you basically a better at your job and be able to contribute to the company. Understanding the current market is a big part of this as well. So knowing what the material is being used for, and then being able to think outside the box with the potential. Now, this is where R&D, exposure to folks in the sales and marketing, sitting down and actually sitting across from and really working with customers can have fantastic potential because I've known people who have, they've wasted a low grade or a poor material that they considered as part of their mine for years and years. And it wasn't until they got customers around a table and started talking about what some of their needs were that you found out, wait a minute, they're making a product here that I've been putting in my waste piles for a long time because of a specific physical characteristic. And you can imagine where that conversation would potentially go. So it's all about really aligning across that value chain to not be afraid to skip some of those steps and really go right to the customer and understand what they need. Understanding processes, understanding the beneficiation, refining, what can be done in that case. And this is an area that I think a lot of geologists tend to feel very uncomfortable with, simply because through education and experience, it's not an area you usually get that much exposure to. Some of the industrial minerals geologists I've known who have worked in or even run plants before have come out the other end of that experience, absolutely changed and really starting to appreciate how geology, metallurgy, geometallurgy, and the processing side are all fit together on what is actually happening through refinement, whether it's flotation or just grinding, different types of grinding, et cetera, of how that modifies the product. And then really also just understanding what minerals and elements are important. And sometimes you'll get the dogma at operations or at plants where they think that, well, we always just have to go for the brightest of the white if we want to compete within the pigment markets. But understanding, well, is that always the case, and what is causing the when you see a degradation in say pigment or brightness, what are the minerals and elements that may be causing that from a deleterious side of it? So again, this kind of all flows into understanding the ore body and the geologist. That's where the geologist is best suited. And so where's the good stuff? What alternatives are out there? You get the idea. So let's start looking at different value creation through geologists. Really, these are the folks who should be, and in most cases, are the most familiar with the ore and with the deposit. So as time goes on, deposits tend to get more complicated. Simply meaning is that you exploit the best stuff first, right? From an NPV point of view, you want to maximize your value in the early years. And then as you get deeper or more complex, or as time goes on, or areas that are mined out, things tend to get harder. It's rare that they get easier. And so, you really want to be able to utilize that ore body that's happened because they are limited. And what I mean by high utilization is every ton of material that comes out of that hole in the ground, whether it's open pit or underground or whatever it may be, you would want to be able to sell that. And this is a concept that you've seen more and more across the mining industry where it's increased utilization, meaning less and less waste. So this is getting creative with waste. Is there a market for the waste? Is there anything from a local construction company that may be able to come in and use inert waste for construction materials? Is there low-grade material that could be used for a different customer specification? A lot of times the geologist is the one who understands this some of the best, and certainly should be the aim of any operational geology. So alignment to the order, the market requirements, kind of touched on this already, is what do the market really need, and understanding that. And overall, just having a good understanding the impact of the geology throughout that value chain. If you get arsenic within your ore body, within your ore, why is it there? Where is it coming from? How do you get it out through processing? And what negative effects does it have on your customers? That sounds like geology 101 to me, really, and that's where it really comes down to. So these are some of the real high level areas that geologists can add a lot of value to industrial minerals operations if they're able to get out there and really sit down and work with all these other different disciplines. So let's look at the flip side of that. Where do we see value destruction? And this is pretty common. This is a human being thing. This isn't geologists or any other engineers or whatever it may be. But just working in silos. Yep. This is my job. I do this, and that's all I do. Don't look beyond that. Folks not involved with any other downstream process. Again, not getting geologists involved with processing or R&D, really understanding what's there. I see this over and over where there's just hiring and retaining of folks who just are not good geologists. And this might sound a bit snobbish or it might sound whatever, but there's almost nothing worse than just getting the wrong person in a chair. And when we think about the industrial mineral space and those limits on how many people are on site, if you're not dealing with somebody who's just really switched on and fantastic, remember that geologist on site, that might also be your surveyor and your geotech and your mine planner and everything else. And there's a time for coaching and mentoring, and there's a time when sometimes people just need to be moved on. And with that, a lot of times, this is a hard one, especially for folks who might have been in the industry a bit longer, is the mobility question. Being able to move around and work in different aspects is really some of the best way to get the experience for geologists to understand customers, to understand sales, logistics, processing, mining, and not just be on site looking at ore and waste. So this is physically working in a plant for a period of time, dealing with with customers and sales needs, and really being exposed to that, and that typically requires people to be mobile physically and without their career. And there's also some bigger picture items that are out there that is destroying value. And in some cases, we see management, company leadership just not acknowledging or flat out understanding what a geologist does for industrial minerals company or what they could do. And I think that's where that latter bit's a bit of an unfortunate one. And then again, this is human nature. It's just a lack of collaboration. There's folks out there who say, no, this is me. I don't want to deal with anybody else. And when you get lack of collaboration across these disciplines, when you bring a lot of smart people who know their stuff together in a room to solve problems, almost always you get better and improved value and solutions to that. So, the folks who are listening in, when you start looking at the geologist, either this is yourself or whether this is what people you work with in an industrial minerals company, some questions to ask, or, are your geos, are they siloed out at operations? Does no one ever talk to them? They've been out there for 100 years and nobody really knows what they do. Or are they actually integrated? Are they involved with every aspect of that value chain? Are they contributing to those sort of improvements? I mean, is this a goal or is there KPIs just, yep, make sure you move enough ore per year. And after that, we don't want to hear from you. Are they contributing to that company strategy and market evolution? I mean, is this just left up to the C-suite? Is this just left up to a small individuals? Or are they actually engaging folks who understand the ore body into understanding where is that company strategy and that evolution going? So I like to use some examples of, there's some fantastic exploration geologists that I've worked with in the past for a very big mining company who were out exploring for things like potash back in the 90s. And company management at the time said, potash, nobody cares about potash. Like, no, we're not going to spend our time on this. And the geo said, no, look, we can get a fantastic position in some world-class areas. And, we think this is going to go somewhere. And of course, management said, no, this isn't part of our MO. And of course, about 10 years later, maybe toward the end of the 90s, potash prices just went through the roof. And we kind of see where we're at right now. The same thing happened with lithium, probably in the early 2000s, where to go pick up land that was prospected in lithium. I knew a lot of geologists who saw, hey, this is fantastic. There is opportunity here from a chemical point of view that getting a lithium carbonate in our portfolio could be beneficial. And of course, nobody's got a crystal ball and could see where it's at today. But if you've got the geos who are out there and pushing these things, but it's just butting up against management, saying, no, not part of it. You see which companies have done well and you see which companies have not pretty clearly. There's also, you can start looking at the more recent asbestos litigation as well. Geologists knew in many cases some of the industrial minerals deposits that had asbestos issues, whether it was real or fabricated as far as actual asbestiform minerals or not. But there was no secrets there. And those items that are going through current litigation have been known about for quite some time. If somebody asked the geologist what are the greatest risks, but I'm not sure that much happened. So, given that central importance of geology in industrial minerals and industry, you would think we would see more executives, more company leadership, and board members and people at the higher level with a geology background. Now, this might be a bit of a rhetorical question here, but unfortunately, you just do not see that. Now, that could be a topic of a whole separate webinar, but I think that's an important key. So this is kind of a quick little how-to when we start thinking about industrial minerals, and obviously I've been talking about geologists, but I think this applies to many professionals, especially technical. When you grab people out of mining schools, typical engineers, right? Most of them producing generalists, right? So you can't expect to grab somebody out of school, throw them into industrial mineral situation and say, yep, go for it, set them up for success. Really requires mentoring, training, that interdisciplinary, getting folks involved. It's not just about a single discipline. And like I said before, is getting these folks involved with understanding the markets, the economics, the logistics. These are absolutely key. and finding people who can move around. And this may be from from the plant to the mine or onto the other side of the planet. But to make sure that development is included if you really want somebody who understands industrial minerals. And this takes a long-term commitment, both from the individual that wants to be there for a long time, but also from the company's perspective. We see more and more these days where companies don't necessarily put enough time, effort in the mentoring and training of people, and it really takes a commitment for companies to invest in their people. And again, identify that talent and really foster the growth. This is two-edged, like most things. Is that when folks are identified as the opposite, then the company shouldn't hesitate to move on. But if you've got a really sharp person who's eager and passionate and willing to learn, that company is going to go a long way if they really foster that person. So that's kind of a bit of a cookbook there for general industrial minerals, especially technical professionals. But I've seen it work before, and oftentimes I've seen it go the other way, which is unfortunate. So I'm going to change speed a little bit here and looking at a couple quick case studies on when geology really paid off. So I'm going to talk a little bit fast, but I want to go through it because this is an actual real life example of where geology can add to the value chain. So this first is based in the US. This was a talc deposit. Big problem we were running into in this case where we basically mined out all the old good stuff, right? This was the high grade, they call it steatite, really great stuff. The operation made the decision to get rid of their ability to beneficiate through flotation. So they were kind of stuck with whatever the ore body provided. And in case with time, this was a lower quality product. And what we were selling was just higher quality specs to the customers, and that's what they expected. So you can't sustain that. So what do? As in most things, you bring a whole lot of smart people who know what they're doing, you bring them around the table, and you start looking at this thing. And that's exactly where it started, is really tying together the folks in the R&D and the marketing side back to the geology. The ore body can produce A, B, and C type material. Well, that's not what we want to sell, but this is what the market can take. And so really providing that end-to-end, okay, how do we align with what's in the ground that Mother Nature has provided to what we can sell? Develop new criteria for those ore types, get rid of the kind of getting the guts out of it of high grading this thing and potentially closing in a couple years to actually maximizing that ore body, utilizing as much as we can, selling as much as we can, probably at lower margins, but better than throwing it on the waste dump and closing the doors on it. Essentially extended the mine life, was able to expand, operations still going. It's been a fantastic success. Another one, now this is an Australian-based iron ore, and a lot of people may argue with me whether iron ore is actually an industrial mineral or not, and we'll leave that for a beer at another time. So there's a big problem on this one where customers were getting high moisture content in the ore, right? And you think, well, is that a big deal? But this stuff's being shipped literally across the planet. And so nobody wants to pay logistic costs on shipping water. It doesn't make a lot of sense. In addition to that, the ore was sticky. It was kind of had clay properties. It was getting stuck to conveyor belts. It was getting stuck in the rail cars. It was getting stuck in the back of trucks. It was just clogging up the screens and the crushers and everything. But when you go in and test it and through drilling and everything else, I said, well, this is good iron grade. What's going on? What more is happening here? Again, get a whole bunch of smart people who know what they're doing. In this case, it was geologists, it was metallurgists, it was mineralogists, it was folks from the plant. Sit down, work together, say, what's going on? Turned out there was this kind of ore type or rock type, we want to call it. It was called an ochreous goethite, and that's an easy one to roll off the tongue, but just abbreviated GOL or GOL. And essentially what this thing was something that had been oxidized and hydrated and turned into kind of like ochre. If you guys know what ochre is, it's kind of like a clay, iron-rich clay. So from a chemical point of view, from a testing, it was high iron, low silica, low phos, low aluminum, all the things that you want. The problem was the physical behavior was just like mush, and it just did not cooperate. So we were able to analyze it, model it, try to understand how to test for this thing. Once you did it, you could put it in your mine plan and account for it. Then you can blend it out, mix it in, not put too much of it together, and basically eliminate all of these problems that were going on by just getting a lot of bright people who know the ore body and know the problems together to sit around a room. Last little quick study here is we take a look at a Argentina-based standard salar lithium carbonate deposit. So this was one of more of like trying to understand, well, how much do we actually have here? And there was problems because it's not just an endless supply of lithium carbonate. It's locked in with a lot of different other, there's some salt and some gypsum and a lot of interlayered and connecting issues that, well, how do we even predict and value this deposit if we're not even sure, every time we drill it, it seems like it's something different. So in a case like this, where we start going back to fundamentals, start thinking about, well, how is this here? What was laid down? What is actually the mode of transport and sedimentation and the genesis of this ore body? So you get a bunch of hydrogeologists and geologists working together to try to drill this thing out and really model in 3D the complexity around the salar. Once you start to understand that variability in the chemistry, why is it higher gypsum here, higher lithium there? You start to improve the understanding of mineral resources. Your planning all of a sudden gets more refined. And ultimately, in this case, we got some higher property valuations because we had higher confidence in what was actually there. Hey, a bunch of smart guys sitting around the room, and they came up with a solution to this. That was what you want. Fantastic. We take kind of an opposite approach. This is sort of a case study. I don't like to point fingers and tell people they're naughty, and so I have left out the company name in this case. But we had talked a couple times, or I'd mentioned a few times, about management engagement and appreciation of understanding how geology can lend to the value of their company. So I've took one of the larger industrial minerals companies in the world and just kind of dissected down on their board of directors, the CEO, and their executive committee. This is the C-suites, right? Chief operating officer, so on and so forth. And so I just looked at their background, right? And not saying that they're not smart people or anything like that. And we start looking at the directors. There was a mining engineer. Hey, that's great. All right, we got somebody who understands something about getting rocks out of the ground. And all that rest, okay, a lawyer, a lot of MBA finance as you'd expected, some agriculture, mechanical. Okay, there's a bit of variety, a bit of diversity, but there's no geologists on there. Nobody understands the rocks. Okay, well, surely there's someone in the executive committee, right, that has a background in geology, at least some degree, a degree in geology, and start looking. Industrial engineer and a chemist. Okay, well, this is good. A sociologist. Oh, why not, right? A lawyer. Well, you got to have one of those or a couple of them. A lot of folks with MBAs in finance. There was one individual, didn't even appear that they had a degree, but hey, I'll give them the benefit of the doubt. And I start looking at this and go, okay, well, if this is the folks setting direction and strategy and where this company is going, how is this actually worked out? And started looking back and did a bit more forensic. And there was a lot of M&A from this company, and a lot of it had so due diligence, you could say, and there was a lot of value, meaning lost value, excuse me, a lot of that lost value in M&A. This is essentially paying more for something, a competitor or a bolt-on operation, another mineral to bring into their portfolio that hasn't really panned out. A lot of litigation that's come with it. There was even a bankruptcy of one of their business units. And just looking at company valuation and stock performance, just they lost nearly half of the value over just say the last 12 months. You compare that with what's happening in the US markets, it's just booming. You go, what's going on here? Now, I will be the first to admit, no, just because you go and you take a geologist and throw it on their board of directors or whatever, that's going to solve anybody's problems, right? But you start looking at an overall sort of systemic issue that's going on with just a lack of understanding of what's in the ground, what these companies are extracting and selling essentially. And if you don't have that geologic input, I think you leave a lot of money on the table. So let's jump into some key takeaways here. Really, industrial minerals are a bit of a different animal. There's a lot of similarities and to traditional mining in some cases, but there's also that can be very unique and very special and very niche. I'd say from a geologist's point of view, it does take a slightly different skill set and an understanding if you want to be successful in it. This is more of a holistic understanding. Geology plays a central role throughout that value chain, as I've tried to illustrate here. And if you want to have success, it's really critical to have the right person the right personnel, they understand that interconnection and that appreciation of how all of this fits together. From a company strategy point of view, I really think it's definitely key to understand what is the connection between your assets, which are the ore bodies and the minerals and the products that are potentially in there, to understanding what the market needs. And whether that's through sales or R&D, and the connection between those. And a lot of the stuff that I've talked about here today, I talk about geologists because I'm a geologist and that's kind of where my passion lies, but I think you can exchange this for mining engineer or salesperson or processing engineer, whatever it may be, and it's going to be a lot of the same stuff. You get the fundamentals. It's understanding more about just the specifics of your discipline. Um, I'd say is that especially on the technical side, I think there's a lot of things that could be lessons learned here. Also, back to the companies and the individuals, I really think I'd love to see a stronger focus on a long-term commitment, really on that mentoring training and knowing the industry. When you see these applications, like a role description that's out there, and someone's hiring a site industrial minerals geologist, for instance. We need 5 years, 10 years experience, and they've got to know, X, Y, and Z. Well, that should be where it starts, but you can't just say go out and grab a really good, say, Nevada gold geologist who's been out there for a while and they understand ore and waste, and you just drop them in a perlite operation. Say, go for it, and they need that support. They need the training and the mentoring. And how does this actually fit in? It's not just about thresholds and grade. And lastly, really, across industrial minerals, the board of directors, executive leadership, strategy makers of some of the companies, big and small, I really think you see success when those members have the discipline backgrounds that reflect those key aspects of the value chain. And this is having representation from geology, from different engineering, from R&D, from processing, from logistics, so on and so forth, and to make sure that that each technical discipline has a voice at the table, and that voice is heard through setting the strategy. So that's all I've got on my bit. I think we're doing all right on time. Probably about another 8 or 10 minutes here for any other questions. And Jackie, maybe I hand it over to you.
Thank you, Eric. That was terrific. Lots of comments so far. The first question is, it seems that a geologist would be good at building bridges to customers, someone that recognizes what we have to sell, but perhaps needing to also understand how it can be used. And the question is, how do you develop those skills in a geologist?
That's an excellent question. One of the companies that I worked for in the past, we had a group called technical marketing, and technical marketing was it was a bit of a hybrid thing where we had folks in sales and engineering, but we also had engineers and geologists who were there together, and it was simply for that purpose to align what's in the ground, what Mother Nature has provided, to what customers need. And it's not a simple question and a simple solution, but it took commitment from the company's management to say this is an area that the customers want and the customers need. And I'd have to say it was really one of those aspects that helped set this particular company out from some of its competitors, because from a customer point of view, they could sit down with a site geologist and with an engineer and a processing person and kind of walk through, hey, why are we seeing this? Or, hey, it would be great if you guys could supply this, that, or the other characteristics, and actually working at a peer-and-peer level. It didn't take a lot. It took the company to say, this is important to us, let's do this, and then getting a couple good geos and engineers and so on, part of that technical team, and then just getting them in front of customers.
Thank you. That answers the question. And I would like to remind our attendees that the session is being recorded. It will be made available on the SME website for you to download in the near future. And we are welcoming questions through the chat panel. Eric, one of our attendees saw the picture of the lithium deposit in your slideshow, and it brought to mind just kind of an off-the-wall question. We've heard about the lithium ore body that's beneath a salt flat in Bolivia. Um, how might exploration geologists have found that beneath the salt flat? Would you happen
Yeah,
to know?
yeah, excellent question. My guess is that over probably the last five, especially within the last five, but maybe back to the last 10 years, anything that's resembled a salar, and this would be primarily in, say, kind of southwestern North America, so Nevada, Arizona, Sonora, going down maybe into Baja, and then Bolivia, Argentina, Chile, Atacama Desert area, and then some areas in Central Asia as well. Anything that's resembled a salar, a dried out lake bed, a salt bed, has been drilled. There's a lot of times where the surface expression doesn't necessarily show lithium on the surface, but it's actually below a layer of salt. So if there was lithium on the surface, a lot of times you can use satellite imagery and multispectral imagery to pick up specific mineral interference and the response of that to find. But in a lot of cases, you just got to put a drill rig out there. And in places like Bolivia and places that are extremely remote, they'll just use, say, a backhoe and just dig a trench. And you dig that trench, and then you've got the liquor, the liquid that's down there that's impregnated with the minerals in there, and start testing that, or digging out those little cones and start sampling those at depth. There's a few different ways, but yeah, you've seen a huge influx of exploration in those areas over the last few years. So that'd be my guess.
Great, thank you. Thank you so much. That seems to be the last of our questions. If any of our attendees happen to come up with something after the presentation, please contact Eric at the address that you see on your screen. And I once again would like to thank Eric for joining us today and sharing your expertise. It was a fascinating presentation. Would you have any final words to share with our attendees?
No, I just think that industrial minerals is a fantastic industry, and I think it gets a bit of a bad rap within mining as being a bit of a backwater in some cases. And the people who say that and do that simply have never worked in industrial minerals, have never appreciated the complexity, and it's unfortunate. So it'd be great to see some better marketing out there and get out there and promote that. That's for sure.
Great. And we did have one final question that just slipped in. Do you have any recommendations for how a customer can effectively partner with their suppliers to encourage collaboration at the geologist level or other deeper technical level?
Yeah, no, it's an excellent question. A lot of times it just comes down to a simple conversation. I find the people within the sales and marketing aspects of any company tend to have a better relationship, at least an initial relationship with the customers. And a lot of times the customers really appreciate and love to hear about who their suppliers are and a bit more about them. I find sometimes a cold email, a cold phone call, or using contacts through sales and marketing folks and getting out there. And yeah, the customers love it. They love to meet and have a conversation. And once you make that initial start, then it's only good things can happen from there. But sometimes it can be a little intimidating of finding out, well, who do I even talk to? You can't just Google a company and call the general line. So I'd say start with your sales and marketing people.
Great. Good advice. Good advice. Thank you again, Mark, for joining us, and thank you for all of our attendees. You will receive an email letting you know when the webinar is, the recorded webinar is available for you to download from the website. And this ends today's session. Have a great day.